Hello, this is Liji from Prog EC, and today I will cover some theoretical stuff which is very much essential for the tutorial series, tutorials in the series. So, without much delay, let me start with variable types. So, in case of statistics, there are two types of variables that are available. Which is, first is categorical variables or qualitative variables, and the second is quantitative variables. So when we say categorical variables, it is those variables which will be having some categories associated with it. It won't be having any numbers or stuffs associated with it. It will be having some categories associated with it. So in layman terms, you can say it will be having some text associated with it. It need not be text all the time, but for a layman understanding point of view, you can say it will be having some text associated with it. And some examples of categorical variables can be marital status. So there are two categories associated with this: married and unmarried, right? Or it can be divorced also. Then gender, it can be male, female. Eye color, it can be black, black, brown, green, etc. But all these categories, it is not assigning any what you say, some particular order or steps to it. So such categories are known as nominal categories, nominal variables. Okay, so if there is no order, even though it is categorical variable, and if there is no order associated with it, then we can say it is a nominal category. But if you consider the student grades, okay, student grades like A, B, C, D, it is again category, but there is an order associated with it. There is a value associated with this A, B, C. Always we know that A is ranked higher than B, B is ranked higher than B, or otherwise we can say excellent, good, very good, such kind of things. Okay, or it can be like in case of salaried people, it can be whoever is falling at the tat slabs. Okay, who is falling at the first tat slab, second tat slab, like that. So there is an order associated with it. Such categorical variables are not known as ordinal variables. Okay, now coming to quantitative variables. Quantitative variables are those variables which are having some numerical value associated with it, in which we can perform some descriptive analysis over there, like average, sum, min, max, etc. So we can add, subtract, multiply, division. So all those things are known as quantitative variables. It will be having, there are two types of quantitative variables, which is discrete and another is continuous. So which discrete variables are those variables which is having some discrete values. Now how many times a person has paid a visit to a clinic. Okay, it can be, or it should be having only numerical values, right? It cannot be like he has visited, it can be like two, he has visited two times, it can be like he visited three times. We cannot just say that he has visited 2.5 times, right? So it is just having discrete values, that is any values that can be counted. Okay, anything that can be counted, it falls in this discrete values. Or how many houses, how many properties are there in his name. So that is again a discrete count that we are having. Okay, nobody can have a 2.8 property in his name, right? It will be either 2 or it will be 3. Okay, so those kinds of things are known as discrete variables. But consider the height of a person, it can be 168.5, or it can be 38.6, or something like that. So it is having a continuous value. Okay, so it can so between two values there can be a number of values in this case. Okay, this those kind of basically speaking, if it's a numerical value having some decimal points, it falls into the continuous category. So those are the variable types that we have. So that is categorical and quantitative. Categorical is, can be strings, which is having, which is again categorized into nominal and ordinal. Nominal is one which doesn't have any order attached with it, but it is categorized. Okay, all the category will be having equal weightage. In case of ordinal, there will be multiple categories, but with different weightage kind of thing. Okay, in case of quantitative variables, it can be discrete or continuous. Discrete will be just the integer numbers which cannot be divided any further, like 2, 3, 4, like that, integer numbers. But in case of continuous, it will be some numerical value with some decimal points attached to it. Okay, now I am having a data over here. So all this: name, gender, age, height, weight, health, visits, all these are known as the data points, or we can say those are the variables. Now consider name, John and Mary. What it will be? Will it be nominal or ordinal? It will be nominal, right? Because there is no weightage, particular weightage or order dash weightage. But and again, it is not numerical in nature, so it is a nominal variable. Again, same in case of gender, it is a nominal variable, right? Now comes age. Okay, age also usually we say in terms of integers, right? We don't divide it into 25.5 when we are uh, telling the age, when we are or entering the age somewhere. Okay, so that is a discrete category over there, discrete variable over there. Then we have height and weight, which can have continuous values, so or float values, so those falls in the continuous category. Then we have health of a person. He can be fit or he needs attention, or the in the basis of that, the person based on the status of his health, he can be divided into many category, right? So, and these categories can have some weightage attached to it. Can ordering can be given over there on the basis of this. So in that case, it becomes a nominal variable over there. No, sorry, ordinal variable over there. Or if it's some feedback, if you have seen the feedbacks in Amazon sites, the ratings that is given in the range of 1 to 5, right? That is again an ordinal variable over there. Now visits, it can be, again, visits can have some integer value only. There it cannot be 2.5 times he has visited. We cannot say that. So it is some integer discrete values, and that's why it is known as it is a discrete variable over there. Okay. Now coming to the types of distributions. In normal case, we'll always be having a bell curve like this. Okay, a bell kind of curve like this. And this kind of distribution is known as Gaussian distribution or normal distribution. Okay, in this, in the middle, we'll be having the mean. Okay, all the average values will be coming over here. And from there, we can have, from there, we can map the standard deviations to it. From mean, okay, there is one standard deviation from here is this one another one standard deviation, that is two standard deviation is this part, three standard deviation is this part. So this kind of graph is known as Gaussian graph. And an empirical property of this Gaussian distribution is that 68.3 percentage of all the values lie in this central part, that is in the middle part. 68.3 percentage of all the things lie over here. Okay, then 95.4 lies between second two SD, two standard between the two SD. This 95 point percentage values lie, and we are within the 3 SD, 99.7 values lies, and all the values the values that lie outside will be very minimal. After 3 SD, the values that lies outside will be very minimal. So excuse me, this kind of graph is known as a Gaussian distribution or a normal distribution. Okay, or it is having a bell shaped curve, as we can see over here. Okay, and this empirical rule, or it can be stated as 68, 95, 99 rule. Okay, where the entire in entire most of the percentage, most of the values will lie in the center, then the rest of the values will lie between the 2 SD, and the last everything will lie between the 3 SD. Okay, so then another kind of graph that we can have is standard normal distribution. In this also, the shape of the graph remains the same. What we are doing here is that in this kind of graph, we plot the Z score of all the values. Okay, so the mean will become 0 and the standard deviation will be 1. Okay, so in this graph, each of the value is taken and its Z score is found out. So what is Z score? Z score is its how much SD a value is from the mean. That is what we find out using Z score, right? So each of these points in the standard distribution, each of these points we take, and if we find the Z score of that value and we plot it, we'll get a distribution like this, where the mean is 0 and SD is 1. Okay, so if there is a value lying over here, we can say that it is 1.5 SD from the mean. Okay, this kind of distribution is known as standard normal distribution. And we'll have a third kind of distribution in which here it is skewed. It's a skewed kind of distribution. See, if you see over here, it is little skewed. Even this is little skewed. But if you take the natural logarithm of the values in this distribution, we'll get a normal distribution over here. Such kind of distributions are known as log normal distribution. So in normal cases, it will be having a skewed appearance, like it will be right skewed or left skewed. But once we take a natural logarithm of the values of in this distribution, we'll get a normal distribution, and such graph graphs are known as log normal distribution. So the three distributions we have covered today is Gaussian distribution or normal distribution. Then we have covered standard normal distribution. How to find z-score, I'll be covering in one of my tutorials that is coming up. And finally we have covered the log normal distribution. These are few distributions that we will be visiting again and again normally, and if some distributions we will be using along with another tutorials, that I'll be introducing those in that tutorial. So with this, let me wrap up this tutorial. I'll be back with more tutorials on statistics. If you like this video, do add your feedback as comments, and do subscribe to this channel for more such videos. Thank you and catch you soon. Bye.